Have you ever wished you had, like, a coding assistant? Someone or something that could just handle all the grunt work while you focus on the really tricky problems?
Oh, definitely. Imagine that, but it lives in the cloud, juggling multiple coding tasks at once, and never gets tired.
Exactly. It sounds almost too good to be true. But today, we're actually diving deep into something that sounds a lot like that.
Right. We're looking at OpenAI's announcement introducing Codex. It's this new cloud-based software engineering agent.
Yeah, agent feels like the key word there. We've got the details straight from OpenAI, and well, our goal today is to really unpack what Codex is, how it actually works, and maybe most importantly, why it matters for anyone involved in software development.
Okay, so let's start right there. What exactly is Codex based on what they've said?
All right, so at its heart, Codex is described as a cloud-based software engineering agent, and it's powered by something called Codex One.
Codex 1, that's a version of their O3 model, right?
Yeah.
But tuned specifically for coding.
Exactly. Think of O3 as the foundation, but Codex One is heavily optimized for software engineering tasks. They've really focused it.
And one of the big things they're highlighting is this parallel processing capability.
Yeah, the idea that it can work on multiple different coding tasks, simultaneously.
That alone sounds like it could seriously change development workflows.
For sure. They list things like writing new features, answering questions about a code base, which, let's be honest, we all need, sometimes fixing bugs, and even getting pull requests ready.
Wow. So quite a range of tasks. And it's not just doing this in theory, right? It has access to the code.
Uh-huh. Each task runs in its own separate cloud sandbox, like a secure little playground. And critically, it's preloaded with your repository.
So it has context from the start. That's important.
Definitely. And maybe the most interesting part is how Codex One learned. It wasn't just fed data.
Right, they mentioned reinforcement learning.
Yes. Trained on actual real-world coding tasks. So it learned by, like, trial and error, figuring out how to generate code that works, follows instructions, and even tests itself iteratively.
That iterative testing,
Yeah.
that's a big step. It's not just generating code, it's validating it.
Exactly. Trying to make it more human-like in its process.
And who gets it first? They mentioned the rollout strategy.
Yeah, initially it's for ChatGPT Pro, Enterprise, and Team users. Then Plus and IDI users are coming soon.
Okay, so targeting professional and team environments first, which makes sense given the capabilities.
So that's the what. But how do you, the user, actually interact with it? What does that look like day to day?
It sounds pretty integrated into the existing ChatGPT interface. You use the sidebar, type in your request,
Okay.
and then you click either a code button if you want it to perform a task, or an ask a button if you're just asking questions about the code. Seems straightforward.
Nice and simple. And then once you hit that button, it spins up one of those isolated environments we talked about.
Exactly. Each task gets its own independent sandbox, but it has full access to read the code base within that sandbox.
And it can write code too, right? Not just read.
Oh yeah. Read, edit files, and crucially, it can run commands.
Like what kind of commands?
Think about your typical dev tools. Running test suites, using linters to check code style, running type checkers. That ability to execute commands is what really makes it an agent, I think. It can interact with the environment.
Right. That makes sense. How long does this stuff take?
They give a range anywhere from 1 to 30 minutes, depending on how complex the task is.
Okay, so not instantaneous, but potentially faster than doing it yourself, especially for complex stuff.
And they mention you can monitor the progress in real time, so you're not just waiting blindly.
That's good. What happens when it finishes? Does it just dump the code on you?
No, it seems more structured. It actually commits the changes within its own sandbox environment. And importantly, it provides evidence.
Evidence.
Yeah.
Like proof.
Sort of, yeah. Citations from terminal logs, outputs from tests it ran. So you can see what it did and why it thinks it worked. Verifiable steps.
Okay, I like that. So after it presents its work, what can you do?
You've got options. You can review the results, naturally. You can ask for revisions if it's not quite right.
Mm-hmm.
You can have it open a GitHub pull request directly from its work. Or you can just pull the changes down to your local machine to integrate them yourself.
So you're still in control. You decide what happens next.
Absolutely. And you can even configure the agent's environment to better match your own setup, which should help make sure the code it writes actually works when you integrate it.
Now, they mentioned these agents.s.md files. What's the deal with those? Sounds like giving the AI some homework.
Huh. Sort of. Yeah. Think of it like a readm file, but specifically for Codex. It's a simple text file you put in your repository.
And what do you put in it?
Instructions for the agent. How your code base is laid out, maybe specific commands it needs to run for testing, any particular standards or practices your project follows.
Ah, okay. So it's like setting up the environment and giving guidelines, just like you would for a human developer joining a team.
Exactly. We all work better when the setup is clear, the tests run reliably, and the documentation is good. AgentTest.md is meant to provide that context for Codex.
Makes total sense. Does it need these files to work?
Apparently not. They say Codex 1 performs well even without them, but having an AgentS.md file can, significantly improve how well it understands and operates within your specific project.
Right, fine-tuning its effectiveness. Okay, performance. They talk about benchmarks. SWE bench verified. What is that?
Okay, so SW Bench is like a standardized test suite for software engineering tasks. The graphic they show uses Pass-It-K.
Pass-It-K.
Yeah, basically it measures the probability that the agent solves a given problem correctly within K attempts. So a higher score means it's more likely to get it right faster.
And how did Codex 1 do compared to older models?
Generally better than O3 High, the previous generation model they compare it against. It shows a higher chance of success within a set number of tries on these standard problems. They do mention excluding some tests that couldn't be run automatically, and they specified the context length and reasoning effort used for testing.
Okay. And the other benchmark, OpenAI internal SWE tasks.
That one's interesting. It's a benchmark curated from real-world software engineering tasks that OpenAI's own teams actually face.
Ah, so testing it on their own problems.
Exactly. And the results chart shows Codex 1 outperforming several other OpenAI models, including O1 High, O4 Mini High, and O3 High, in terms of accuracy on these internal tasks. It suggests it's pretty capable on practical, real-world challenges.
Okay, but with AI writing code, safety and trust are huge concerns. How are they addressing that?
They're definitely emphasizing that this is a research preview and that security and transparency are priorities. A big piece is the verifiability. We talked about the citations, logs, test results. That lets you audit what it did.
Right. And what if it's not sure about something or a test fails? Does it just guess?
No, the announcement says it's designed to communicate uncertainty or test failures clearly. So it should tell you if it ran into problems, allowing you to make an informed decision rather than just trusting blindly. Human oversight is still key.
What about preventing misuse? Could someone use this to write malware?
They've thought about that. They say it's been trained to identify and refuse requests for malicious software development while still being helpful for legitimate tasks. They mentioned enhanced policies and safety evaluations, too.
Okay.
And they even published an addendum to their O3 system card detailing these safety checks.
And the actual environment where the code runs, is that locked down?
Seems like it. It runs in an isolated cloud container, and crucially, internet access is disabled during the task execution.
Oh, okay.
So it can only interact with the code you give it and any pre-installed dependencies. It can't just reach out to the web, which is a major security measure.
Another point they made was about alignment making the code more human-like.
Yeah, aligning outputs with human coding preferences and standards. The goal was to make Codex 1 produce cleaner patches, as they put it.
Cleaner patches, meaning
Code changes that are structured more like a human would write them, easier to review, and ready for integration. They claim it does this more consistently than the older O3 model, making it easier to work with, basically.
that makes sense for adoption. It's interesting that their own teams are using it already. What are they using it for?
Mostly for those tasks that are necessary but maybe a bit repetitive or tedious. Things like refactoring code for better structure, renaming things consistently, writing unit tests.
The essentials, but maybe not the most exciting parts of the job.
Exactly. Also things like scaffolding new features, wiring up components, fixing simpler bugs, and even drafting initial documentation.
So it sounds like it's becoming part of their workflow, changing how they manage tasks.
Yeah, they mentioned new team habits emerging, like triaging tasks, planning work differently, and offloading some of this background work to Codex so engineers can focus on the harder problems.
And they had external testers too. Companies like Cisco, Temporal. What did they find?
The feedback seems positive and covers a range of uses. Accelerating ideas into actual features, debugging, testing major refactoring jobs, handling small repetitive tasks, and even just helping developers get up to speed on unfamiliar code.
So a pretty broad set of applications already.
Yeah, the advice seems to be give it well-defined tasks. Maybe even try giving different tasks to multiple agents at once and see what happens. Experimentation seems key right now.
Interesting. Okay. What about the command line? There was already a Codex CLI, right?
Yes, that lightweight open source tool. It's getting an update. They're releasing a smaller, faster version of Codex 1 for it.
A mini version.
Essentially, yeah. Based on their O4 mini model, optimized for speed. Good for quick questions and edits directly in the terminal. It's called Codex Mini Latest.
And that's the new default for the CLI?
Yep, and it's also available via their API. They plan to update this mini model regularly, too.
And they made connecting easier. No more messing with API keys as much.
Right. You can now just log in using your regular ChatGPT account, and it handles the API key setup automatically. Plus, for Plus and Pro users doing that, they're throwing in some free API credits for a while.
Nice. Okay. Let's talk availability and cost. We know who gets it now and who's next. What about after the initial free period?
Pro, Enterprise, Team now, plus Edu soon. Initially, they're saying access will be generous and free.
Okay.
After that, they'll move to rate limits and flexible pricing. They did give specific pricing for that Codex Mini latest model on the API. It's based on input and output tokens with a discount if you reuse prompts.
Gotcha. And limitations, what can it do yet?
Well, it's still early days, a research preview. Right now, no image inputs, so maybe less useful for some visual front-end stuff.
Okay.
Also, you can't really guide it or correct it while it's working on a task. You have to wait until it's done.
Okay. Less interactive in that sense.
Yeah, and they acknowledge that delegating a task like this takes longer than just editing code yourself interactively. They compare it to, like, asynchronous teamwork with a colleague you hand off the task, and it comes back later.
That's a fair analogy. It's a different mode of working than, say, a real-time pair programmer AI.
Exactly.
Yeah.
But the potential is offloading those bigger chunks of work. Looking ahead, OpenAI's vision seems to be about developers focusing more on the high-level strategy and creativity.
While delegating more routine tasks to agents like Codex.
Right. They see a future blending AI tools, human expertise, and maybe these asynchronous multi-agent workflows becoming more common.
And they're planning more features?
Oh, yeah. They hint at making the agents more interactive, allowing guidance mid-task, collaborating on the approach before coding starts, getting proactive updates, and much deeper integrations.
Integrations with what?
GitHub, the Codex CLI itself, the ChatGPT desktop app, issue trackers, CI/CD systems, basically weaving it more tightly into the entire developer ecosystem.
The productivity potential seems huge, but it also raises questions about the future of development.
Absolutely. They mentioned they're actively working with partners to understand the broader impacts on workflows, skills, whole landscape.
And finally, that appendix detail about the system message for Codex 1 was pretty unusual, sharing the internal prompt.
It is quite revealing. It gives you insight into its default instructions. Things like how it should handle Git work in the existing repo, don't make new branches, commit changes, check Git status, what to do if pre-commit checks fail, and also how it should use those agents as .md files, their scope, which instructions take precedence, the need to run checks.
And the citation rules were very specific, too.
Very. Exactly how to format references to file paths, line numbers, terminal outputs. They even tell it to prefer citing specific file lines over just general terminal output when possible. It all points back to that emphasis on verifiability and transparency.
Okay, so let's try to wrap this up. Codex. It's this cloud-based AI software engineering agent powered by the new Codex 1 model.
Right. It tackles multiple coding tasks in parallel, in secure sandboxes, using reinforcement learning to generate human-like, testable code.
Provides evidence for its work, can be guided by these agents s.md files. It really does feel like a significant step.
Yeah, it points towards a future where development might involve more delegation to AI, freeing up humans for more strategic thinking.
So for you listening, this isn't just another tool dropping. It could genuinely change how software gets made. It's worth thinking about how something like Codex might fit into or even reshape your own work or learning process down the line.
And that leaves us with a big question to ponder. As AI gets better and better at these complex coding tasks, what does that do to the role of the human developer? What skills become even more valuable, and what new areas should people focus on learning as this technology evolves?